So here we have number 10. So we're going to use the graph of f to find the indicated values. So let's first go ahead and break this down. Let's break down what f of x is. So f of x is also your y, right? So f of x is actually what's called function notation. So your x is obviously right here, right? So your x is your x. And then your f of x is your y. So I know it's a little bit kind of simplified, but once we understand what this is, then it's a little bit easier to understand and more quickly see what the indicated values are. So the x inside of here is your x, and this is your input. So what you're inputting into a function. And now your f of x is your output, your y, okay? So the reason we like function notation is because we can easily specify what we're plugging in for x to get our y, all in one symbol. So if we put in 7 and we get 15, well, we know that our input is 7, and when we input 7, our output is 15. Okay? So let's take a look at f of 3. So f of 3, when we reference it back to our function notation, the 3 is our x value. So we're going to look on the graph to see where on the x-axis the value of 3 is. And that's right here. Now to find f of 3, remember f of 3 or f of x is our y value. So our y value, where x equals 3, is 1.5. So f of negative 3 equals 1.5. Now to find f of 0, when we relate it again back to our just regular function notation, f of x, our 0 is our x value, and our f of 0 is our y value. So let's go onto the graph and see where the x-axis equals 0, which is right here. And the function, the f of 0, which is our y value, just so happens to also be 0 because it crosses through the origin and the coordinates for the origin are 0, 0. So when you input 0, you output 0 as well. And you can also label this coordinate. So this would be 3, 1.5. Okay? And that is how you find indicated values using a function notation.